the number of real solutions of the equation sine inverse of whole summation I is equal to 1 to infinite x to the power I plus 1 minus x summation of I is equal to 1 to infinite x by 2 to the power I whole is equal to pi by 2 minus cos inverse of whole summation I is equal to 1 to infinite minus x by 2 to the power I minus summation I is equal to 1 to infinite minus x to the power I. Lying in the interval minus half to half is, and it's given, here we consider the inverse trigonometric functions sine inverse x and cos inverse x. Assume values in minus pi by 2 to pi by 2 close bracket and 0 to pi close bracket respectively. According to the given question, we have sine inverse of something is equal to pi by 2 minus cos inverse of something. But there are summation terms that are inside the bracket. First, we need to solve the summation terms. And we see that they are in the form of a infinite geometric progression. First, we need to find the value of an infinite geometric progression. To the question, it's given sine inverse of summation x to the power I plus 1. I is equal to 1 to infinite minus x into summation of I is equal to 1 to infinite x by 2 to the power I is equal to pi by 2 minus cos inverse of summation I is equal to 1 to infinite minus x by 2 to the power I minus summation I is equal to 1 to infinite minus x to the power I. The summation terms are this term, and we have another summation term. This is the third summation term, and we have the fourth summation term. For that, we will use just one formula, which is the infinite geometric progression, summation of an infinite geometric progression. We write that in the formula chart. Formula chart. If there is a infinite geometric progression like AR, where R is the common ratio, AR square to infinite terms, then we have the summation of this infinite geometric progression, summation of A plus AR plus AR square plus is equal to A divided by 1 minus R, where A is the first term and R is the common ratio. Right, A is equal to the first term, R is equal to common ratio. Doing that, if we denote this by 1, the second by 2 and 3, 4, we have the first term as summation I is equal to 1 to infinite x to the power I plus 1, which is equal to x square plus x cube plus up to infinite. We denote the first term as A. A is equal to x square for this, and the common ratio is equal to x cube by x square is equal to x. So the summation turns out as x square divided by 1 minus x. We have the second term as summation I is equal to 1 to infinite x by 2 to the power I is equal to x by 2 plus x by 2 square plus x by 2 cube plus dot dot dot, which is basically, here we have a is equal to, the first term is equal to x by 2 and the common ratio is equal to x by 2. So the summation is x by 2 divided by 1 minus x by 2 is equal to x divided by 2 minus x. We have this was the second term, and we have the third term as summation I is equal to 1 to infinite minus x by 2 to the power I is equal to minus x by 2 plus x by 2 square minus x by 3 cube plus dot dot dot. Here a is equal to minus x by 2 and r is equal to minus x by 2. That implies the summation is minus x by 2 divided by 1 minus of minus x by 2, which is equal to minus x by 2 divided by 1 plus x by 2, which is equal to minus x divided by 2 plus x. We'll write the fourth term here. Fourth term is equal to summation I is equal to 1 to infinite minus x to the power I, which is equal to minus x plus x square minus x cube plus x to the power 4 dot dot dot. Here a is equal to minus x and the common ratio is equal to minus x as well. So the term is, summation of term is equal to a divided by 1 minus x is equal to minus x divided by 1 plus x. So we have all the summation terms here, and we can write the equation or the question given at first in terms of x only and not in terms of summation. We have sine inverse of x square divided by 1 minus x minus x into x divided by 2 minus x is equal to pi by 2 minus cos inverse of. minus x divided by 2 plus x minus of minus x divided by 1 plus x, which is equal to sine inverse of, taking x square common in the first term, we have x square whole into 1 by 1 minus x minus 1 by 2 minus x is equal to pi by 2 minus cos inverse of x into 1 by 1 plus x, taking this term as this is positive, so this term comes first and second becomes this term, minus 1 divided by 2 plus x. Now if we take the LCM of these terms and these terms here, we have, this becomes 1 minus x into 2 minus x, and this is 2 minus x minus of 1 minus x, which is equal to 1 divided by 1 minus x into 2 minus x, and this term here is 1 plus x into 2 plus x, and we have in numerator we have 2 plus x minus of 1 plus x is equal to 1 divided by 1 plus x into 2 plus x. So the summation simplifies as we'll write the first term here. So the term becomes sine inverse of x square divided by 1 minus x into 2 minus x is equal to pi by 2 minus cos inverse of x divided by 1 plus x into 2 plus x. And we'll use a inverse trigonometric formula here, and we'll write that in the formula chart. The formula we will use here is cos inverse of x plus sine inverse of x is equal to pi by 2. That implies this changes into sine inverse of x divided by 1 plus x into 2 plus x, and this is equal to the LHS, which is as usual sine inverse of x square divided by 1 minus x, 2 minus x. To find the solution, we equate both the quantities which we have in bracket, which is this. Then we get x square divided by 1 minus x into 2 minus x is equal to x divided by 1 plus x into 2 plus x. We see that from this equation, we write this equation as something 1. Then we know x is equal to 0 is one of the solution, because if we put x is equal to 0, the LHS and RHS both becomes 0, because there is a x square and a x term in numerator. So 0 is one of the solution. We got our first solution. Then we need to solve the cubic equation that we'll get from cancelling x on both sides in numerator. That is x divided by 1 minus x into 2 minus x is equal to 1 divided by 1 plus x into 2 plus x. That implies the equation becomes x into 1 plus x into 2 plus x is equal to 1 minus x into 2 minus x, which is equal to x into, and this is x square plus 3x plus 2, which is equal to x square minus 3x plus 2. That implies we have x cube plus 3x square plus 2x is equal to x square minus 3x plus 2. From this equation, we have to find the number of solution which lies in the interval minus 1 by 2 to 1 by 2. So this is a cubic equation, and we bring all the RHS term to the LHS side. We have x cube plus 2x square plus 5x minus 2 is equal to 0. Now we want to check if this is an increasing function or not. If this is an increasing function, then we can put the root formula, that if there is a value of the function where it is negative and the value of the function where it is positive, then there must be at least 1 0 between those two values. To do that, we consider this as f of x, and we find f dash x, which is equal to 3x square plus 4x plus 5. Now we have to find if this is always greater than 0, or if this is always less than 0, or it is not monotonic in nature. To find that, we have to write it in such a form so that there is a square term plus there is a addition term. To do that, we'll just rub this side so that we know what equation we are finding. We have f dash x is equal to 3x square plus 4x plus 5. This can be written as 3 whole into x square plus 4 by 3x plus 5 by 3, which is equal to 3, and this is x square plus 2 into x into 2 by 3, and we can add 2 by 3 square, and we can subtract 2 by 3 square, so that the total RHS is the same as that was before, and there is a plus 5 by 3 term. This is equal to 3, and we have this term as a square plus 2ab plus b square. This can be written as x plus 2 by 3 whole square, and we have this term which is minus 4 by 9, and we have plus 5 by 3. This is equal to 3 whole into x plus 2 by 3 square, and we have this as, we take the LCM as 9, and we have minus 4 plus 15, which is 3x plus 2 by 3 square plus 11 by 9, which is always greater than 0. That implies the cubic function that we found, this one, is always greater than 0. So if we see that there is, we'll keep the equation and we'll rub everything else. This is the equation, and we have to find the roots of this equation. We see that f of 0 is equal to minus 2, and f of half is equal to 1 by 2 cube plus 2 into 1 by 2 square plus 5 into 1 by 2 minus 2, and this term is positive, so this whole term is greater than 0. That implies there is a root between f of 0, the root between x is equal to 0 and x is equal to half, and we got another root as x is equal to 0. That implies this is our first root that we got. That implies total roots is equal to 1 plus 1, which is equal to 2, which is the final.